Good morning to all of you. Uh, we are in lecture 14, so we are going to have a review of units 3 and 4. That is the review of Apache Pig. Okay, so we'll be discussing these things and some other operators if time permit. So kindly pay attention, all of you. So if we talk of Apache Pig, you know the first step obviously to learn Pig would be to install it properly. And most of you have already done it. So just going through the installation steps, obviously downloading it, then unzipping and making the relevant directories and making the changes in your .bash rc file with these pig variables, the environment variable and all, right? Now let's discuss about pig. You know, pig provides an engine for executing data flows in parallel. So sort of a parallel processing of data in pig on Hadoop. And for this, we have a language, Pig Latin, okay, for expressing these data flows. The strength of Pig is the inclusion of, numerous operators which make our task of analysis very easy. And apart from that, you can also create your own functions for reading, processing, and writing of data. And Pig, is an Apache open source project, which means that it's free for, download, and you can use it and you can also contribute to it. A Pig runs on Hadoop, uses both your HDFS and the MapReduce. HDFS to store the huge files which we need to analyze, and MapReduce to do the analytics or the processing. And whatever we do in Pig, in the background, it is converted into a MapReduce job that we are all aware of, all right? And some information about HDFS, which you already know, which we have reviewed also, that in Hadoop distributed file system, we have large files which are broken down into large blocks and which are distributed across different machines. These blocks are replicated also so that we have the availability of the files at all times. And the Pig reads input files from HDFS most of the time by default. It can also read the files from the local file system. And it uses HDFS to store intermediate data between MapReduce jobs and writes its output to HDFS, or it can also write to the local file system. So as I discussed that when you have a Pig script with you, it is converted into MapReduce jobs which are executed and the results are stored in HDFS. So MapReduce is a simple but powerful parallel data processing paradigm. That is, it's a parallel data processing model, and every job in MapReduce has three main phases: the map phase, the shuffle phase, and the reduce phase. And in the map phase, the application has the opportunity to operate on each record in the input separately. And when you have the map phase, many maps are started, hundreds and thousands of maps are started, so that while input may be in huge size, gigabytes or terabytes, if we have a large number of machines in the cluster, our map phase can usually be completed under 1 minute. That is the idea. That is, in the map phase, you operate on each record in your input file separately. And how it is done is that we take some key on the data on which the processing needs to be done. So for example, if we are using web server logs for a website, then user ID would be the key, okay? And every record for a given key will go to the same reducer, okay? And in the shuffle phase, which is after the map phase, data is collected together by the key the user has chosen, and then it is distributed to different machines for the reduce phase, okay? And in the reduce phase, the application is presented each key together with all the records containing that key. So this is the theoretical aspect of map, reduce, and shuffle. But let's take an example to understand this. So we'll be discussing a word count program of map reduce to understand how these map, reduce, and shuffle phases work. So this word count program is also known as the hello world program of MapReduce. Okay. Suppose we have an input file, a text file, okay, and there are many lines in that. maybe hundreds, thousands of lines. So in the map phase, your each line is assigned to a map, okay, and then it is split out. It splits out each word into a separate string, and for each word it will output the word and a one. Suppose now we are counting the number of words, so each map task picks up one line, okay, and then splits out each word into a separate string and outputs the word and a one, that it has counted that word once. In the shuffle phase, we use the word as the key and hash the records to reducers, which count up, sum up the total numbers and then tell you that occurrence of each word, how many times each word occurs. For this, let's take an example of this file which contains the nursery rhyme Mary Had a Little Lamb. You can see there are 4 lines. So I've taken a short text file for explanation. We have a text file, Mary Had a Little Lamb. These are the contents of the text file. I want to count how many times each word occurs in this file, right? So for this, I will be using this MapReduce word count program. Okay. Now each line is sent to a different map. Okay. So if we have 4 lines of text, we'll have 4 map tasks. Okay. Then you can see this example here, that each line, we have 4 lines, each line is assigned to a map, and what it does is it splits the words and outputs the word and one as the output, so that it has read the word once. Okay, and in the shuffle phase, the outputs of these maps is given to various reducers. In our example, we assume that all the words starting with A to L would be picked up by reducer 1, and from M to Z by reducer 2. So this way you can see we can count the number of words in a text file. Now the same idea could be given to a small file as well as to a large file. So if you have a large file, even then it will count the number of words very easily and in a very short duration of time. All right. So this is the word count program. Now all of you are aware about it, that first we load the file, okay, and then we use the tokenize and the flatten. The tokenize and the flatten operators, you know that tokenize would convert a line into the strings, and flatten would flatten that to each new line. Okay, and then you can do the grouping of words, okay, so that the similar words come under one heading, and the count, and you can use the count function to count the occurrence of each word in the file. All right, so these things we'll just see when we now start the pig session in our terminal. Okay, so I'll be coming to this word count program then. Okay, so if we have anything needs to be asked about this word count program, which will be running soon, or the map reduce and shuffle phases, you can please ask now. Okay, you'll be asking after some time, I suppose. So let's move ahead. So let's discuss about Pig Latin. As we discussed initially, that it's a data flow language. That means you describe how data from one or more inputs should be read, processed, and then stored to one or more outputs in parallel. And these flows could be simple linear flows like the one we discussed in the word count example, or it could also be some complex workflows. Okay. Now, mathematically, a Pig Latin script, whenever you are dealing with a Pig Latin script, it is first converted into a DAG, that is a directed acyclic graph, where in the graph the edges are data flows and the nodes are operators that process the data. And Pig Latin is not similar to the programming languages that you people have worked with. There are no if statements, no for loops in Pig Latin, because it is a data flow language rather than a control flow language like C, C++, Java, etc. Okay. Now where we can use Pig, okay, so we can wherever you use Apache Hadoop, Pig can be used. Okay, at Yahoo, more than 60% of the Hadoop jobs are Pig jobs. Twitter is using Pig for its log analysis, for sentiment analysis. By sentiment analysis, we mean that what is the sentiment of the people that is expressed through tweets. We can also pick out relevant information from tweets. So that would be the mining of tweet data. Okay, so Twitter is using pig extensively. Then PayPal is using pig to analyze transaction data and fraud detection. Analysis of web logs is also done by many companies using pig. So these are some of the use cases of pig. We learn pig here to learn some analytics, which of course would be useful later on at your workplace. Now, next we have the pig philosophy. You know what pig is based on. So, pig is based on 4 founding principles that define the philosophy of pig. Okay, and these principles would give you a broad or a helicopter view of this technology. Namely, pigs eat anything, pigs live anywhere, pigs are domestic animals, and pigs fly, right? So let's see if some of you can, discuss about this pig philosophy. Can raise your hands. You need to explain all the 4, right? Raise your hands to answer this question. Interesting discussion it would be, that what is the meaning of all these 4 pig philosophies. Only one person has raised hand, Prince Agarwal. That's such a simple question. We are reviewing it. We are not learning it for the first time. Keep on raising your hands. Okay, let me pick up one person. Yeah. Vishal Kumar, unmute yourself. If somebody is not responding, I'll remove that person from the class. Yes, Vishal.
Sir, good morning.
Good morning. Vishal, please explain these 4 things that you see on the screen about pig.
Sir, I don't know.
How will you pass then?
Sir,
No, my next question is, how will you pass? I'll ask you the same things in the Viva. If you don't answer, I'll fail you. This is a basic. We are learning it for the second, third time, I suppose. Kindly see all the videos that we have, posted. Okay, go through them, please.
Yes, sir.
Yes, Ritika, please answer.
So pig eats anything. That means that any kind of data can be processed using pig. It can be structured, semi-structured, or unstructured. And
Okay.
pigs live anywhere that it can be run both on the HDFS or in the local file system.
Okay.
And third one, pig are domestic animals, that they are very user friendly and easier to use. That is, more complex programs can be done using the simpler queries.
Okay.
And fourth one is pigs fly. That means the processing speed of pig is very fast. We can process the records very fast by using a huge number of mappers and reducers.
All right. Very good, Ritika. Correct
Thank
answer.
you.
I hope all of you have understood. You can lower your hands, please. Yeah. So that is the pig philosophy. Ritika has explained very nicely. You can note it. This is important because that way you understand what pig is meant to do, right? Next is the data types. Since pig is a Apache Hadoop ecosystem component, which Hadoop is based on Java. So most of the data types that you see here would be like Java data types only. So we have 2 categories of data types in pig, that is the simple and the complex data types. In simple data types, we can see the list. Okay, now you've worked with all of them, I suppose. Date time we have worked, we've seen the strength of the date time data type, in which you have the date, the time, and the time zone. You worked with this. And the remaining ones are similar to your Java types, which I'm sure that you will work with or may have worked with. Then in complex data types, we have maps, tuples, and bags. You've used each one of them. Okay, map is a key value combination, tuple is a set of fields, bag is a collection of tuples. Like we have other operators also, you use them, greater than, less than, relational comparison operators are there. You combine the conditions with the Boolean operators. Then pig uses a large number of identifiers. Okay, so identifier would be the name of any field that you use in your data set, or the relation that you use for processing the variables, and so on. So identifiers always begin with an alphabet, and they can be followed by letters, numbers, and underscore, right? So like in pig, most of the work that is done is that one relation is transformed into another. The first step obviously is that we load our data set into a relation, and then we do a lot of data flow, with data flowing from one relation to another with the use of various operators. So at any time, if you need to see the schema of a relation, that what a relation looks like, what are the fields, what are their data types, then you can use the describe operator, okay, along with the relation name, right? Okay, next is the grunt shell in pig. So now once we have understood how pig should be installed, how pig works, how the MapReduce is in the background when you write some pig queries, okay, how MapReduce works, what is the word count in MapReduce, and then what are the use cases of pig, and what is the philosophy of pig. Once you have learned this, then and also the pig data types, once you have learned all this, we would like to start working with pig. So grunt shell is the place where you can work with pig, and this shell can be used for submitting your pig Latin scripts, that is working with your pig code, controlling the jobs. Like you see, when a lot of processes are working in parallel, you need to control them, giving priority to some and minimum priority to some other. So you can control jobs also, that can be done by admins. And accessing the file systems, if you need to access your file system files, both from your local as well as HDFS, then you can do all these tasks in your grunt shell. Okay, so obviously the next question would be how to invoke the grunt shell, right? So you can see in the graphic also that grunt shell can be invoked in 4 modes: the local mode, the MapReduce mode, the Tez mode, and the Tez underscore local mode. Okay, it should be Tez underscore local, right? And by default, the default mode in which pig opens is the MapReduce mode. Okay, the default mode in which the pig opens is the MapReduce mode. So how you can open pig? Either you can just write pig, that will open the grunt shell in the MapReduce mode, which means that you can use files from your distributed file system. And if you want to specify a mode on your own, then you can use the -x option, which stands for execution type. Okay, so if you write pig -x local, then it would open the grunt shell in the local mode, meaning which you can access the files only from your local file system and not from your distributed file system. Okay, then further we have fs and sh commands. So let's go to our terminal now. We'll work with all these operators and commands side by side. So I'm going to open up a terminal. Okay, and let's work with some commands here. So if I write pig -x local, okay, see on screen what happens. I'm trying to open pig in local mode. So by default also it checks for the local mode in the first time. Okay, it checks for the local mode first time, and if you have mentioned local mode, it will pick up the local mode. Okay, if I write here pig -x Tez, note this thing very carefully. The sequence in which it searches for your modes. Okay, so I'm writing pig -x Tez. Sorry, I should be out of the grunt shell. So I've written pig -x Tez. See, it first looks for local, then for MapReduce, then for Tez underscore local, then for Tez, and then it picks up Tez as the execution type. Okay, and if Tez or Tez local environments are there on your cluster, then you can work with these environments. But for most of our discussions, we have limited it to the local and the MapReduce modes. So if I show you now, if I just write the pig here without any mode, it will pick up the MapReduce as the default mode. We are in grunt shell, so we can write a quit here to come out of the grunt shell. Okay, we can also use Control D to come out of the grunt shell. Okay, so just write pig here to see you see, it tries local, then MapReduce, and then picks up MapReduce as the execution type. So if you don't mention anything, any mode, then by default, mode of pig is MapReduce. Remember this thing, right? So now we are in grunt shell. Okay, so let's have a look at this fs and sh commands. Okay, so while in grunt shell, if you want to work with your file system commands, that is your hdfs commands, then you can use fs. So the idea is simple, just write fs, the command name, and whatever parameters you want to pass. So instead of hadoop fs, while you are in grunt shell, you can simply write fs. Okay, that is the usage of fs command. Similarly, if you are in grunt shell and you want to use the bash shell or whatever shell you are using, then you can start the command with sh. Okay, so I'll give you an example here. I'm writing sh and then I'm writing ls. So what this is going to do is to list the files from your bash shell. You can see the list of files. Okay, you can also use ls with other options. Okay, ls hyphen l like this. Okay, so sh is like used like this. So let's now move one file from our local file system to the distributed file system. So for that you write usually hadoop fs, right? But while in grunt shell, it can be done simply by writing fs, then a hyphen put, and then maybe I can transfer this file. Say word count is a file there. Let's transfer it to the root of HDFS. See, I'm using fs command. I'm in grunt shell. I'm using fs, a file system command, similar to your hadoop fs command, but just write fs and then the command that you've used before, fs hyphen put, the name of the file and the destination. So this will transfer this file to your distributed file system. So we can just open our distributed file system here, and let's open up this, the local host we can open. You remember localhost 9870 to see the web UI, and I hope you can see the file here. You can see the word count file here that has been copied here. Okay. And now what we can do here is, we have seen the working of fs and sh commands, right? Now let's have a quick poll. The poll is in front of you now. Limited time, please. Not more than 20 seconds. I'm closing the poll now. Sharing the results with you. Somebody, two of you have answered any of the above. Can you please raise your hands? Those of you who have entered the option any of the above, you need to raise your hands, please. Okay, one person has given the answer as local. Who is that person? Raise your hands, please. All right, no problems. I'll look it into the poll result after the meeting. Then I'll talk to you. If you are not willing to raise your hands now, no problem. I see I'm recording everything, so yeah. Yes, Ritik. What happened?
Sir, by mistake, sir.
What?
I know that the answer was MapReduce.
No, but how is the mistake done when there are 4 options?
Sir, actually, sir, I am using the mobile. My mobile screen is not working properly, so that's why.
So there are chances that you may not be able to, pass this subject if your mobile screen stays like this. Do you understand this thing?
No, sir, this is the like this had happened the first time.
Okay, fine. Okay, Prabjot, yes.
सर वो नेटवर्क इशू ना पहले पॉल शो नहीं है जरूर से वो पोल बंद करना क्या फिर और शो है या फिर
नेटवर्क इशू क्या होता है? आप अमृतसर में
सर
रहते हो?
मोबाइल
Are you in
यस सर
Amritsar?
सर यस
Are you using a data connection or a broadband connection?
सर डाटा
घर में ब्रॉडबैंड नहीं है?
नो सर
क्यों? कहाँ रहते हो अमृतसर में?
सर सुल्तान मिन रोड
वहाँ पे ब्रॉडबैंड है कि नहीं? जब
सर
पढ़ाई
ब्रॉडबैंड नहीं
करनी
है
है, ब्रॉडबैंड नहीं है ना, तो ब्रॉडबैंड लगवाना चाहिए जब सारी पढ़ाई ऑनलाइन हो रही है. Then you should, you should spend some money on that. That's important. That's not
यस सर
the network issue and you were not able to, that's, I don't take that answer. Anyways, these polls are important while we are evaluating your performance. That's why I'm asking you so many times to answer it properly. Okay, let's see if there is something else, another poll. No, not yet. Okay, so let's get back this. We have done this FS and SH. I hope it's clear. How do we use these? Okay. Then the next we have the utility commands, the help command, you can check it. Then the history command is there in gun shell, which gives you a history of all the commands that you have used. Okay, and you can rerun those commands. The history command is usually numbered, so you can remove the numbering by using the -n option. We will see this command after some time. Once we start using some commands, then I'll tell you how to use the history command and what are the what are the things that you should keep in mind while using the history command. Then we have these commands, so we'll discuss them also. The run and execute commands we'll discuss, and then how to run the pig Latin code. All this I'll discuss now, but I'll begin with the very basic pig data analysis operators. So there are 3 pig data analysis operators which you should know to start working with analytics with pig. Okay, the first of these is the load operator, the second one is the dump operator, the third one is the store operator. So most of you are aware how to use it, but kindly pay attention now, okay, so that you understand how to use them. For this I'm going to first let's see whether these services are on or not. So our distributed file system services are on. Okay, name node, data node, and secondary name node. So I'm going to start pig in the default map reduce mode so that I can use the files from my distributed file system. Okay, and those of you who do not know the load, store, dump, and other operators, kindly pay attention here. You will learn it today. All right, we have done it so many times, but this is another review for these pig operators, so kindly pay attention. Okay, let's see what files are there in our distributed file system. For this we can write fs -ls. Yes. So I'm trying to find the files which are present at the root of the distributed file system. So you can see emp.txt, mary.txt, these files are there, Shakespeare, test, so many things are there, right? So let me open this file emp.txt, our emp dataset. When you are working with your dataset in the part B of your lab, you are required to work on a similar way like I would be doing it, right? So kindly see how the load operator is done. Okay, so I take some relation name, say I take the relation name as m. Okay, so most of the operators that you use in pig have a relation name on the left in which the result is stored, right? Most of the operators I've said. So let's write load here. I'll first write the syntax, then I'll discuss with you. Remember, we are in MapReduce mode, so we are going to work with the distributed file system files. Okay, so I'm writing, as you all know, there are 8 fields in the emp dataset. I'm loading it into the emp relation. So the load operator is there, followed by the name of the file in single quotes. You must mention the entire path. Okay, so I'm mentioning that there is a file emp.txt below the root in the distributed file system, and then using pig storage, this will tell you that how the file is stored, what mode, whether it is a tab separated file, it's a comma separated file, it's a space separated file, and so on. So we know that our emp file is comma separated. Okay, I'll just first load this. I'll go slow so that you don't have any confusion. I want to list the contents of the emp file, so I'm doing it here. Just miss this. Some problem with the keys. Yeah, we need a hyphen here actually. Okay, so you can see our emp.txt file is a comma separated file, comma separated values file. That is why when I load the file, I mention the pig storage function as a comma here. Okay, if the file is a tab separated file, then you can use a pig storage function here, and you can mention a \t here. But since tab is the default mode, so you can do without it also. You don't need to mention using pig storage while if your file is tab separated. So right now our file is comma separated, so we'll go like this. And I've named the fields, see, I've named the fields as A, B, C, D, E, F, G, H. 8 fields are there. As you all know, the employee number is the first one, then the name, then job, then MGR number, then hire date, salary, commission, and department number. Okay. So I've not mentioned any data types with the field names. Okay, so if I don't mention any data types, by default it would be byte array, as you know, right? So if I describe the schema here, say describe and then the relation name, so it will tell you that the relation name is emp and the field names are A, B, C, D, E, F, G, H, and all the fields are of type byte array. Okay, so I can specify an explicit type for all. So maybe I can go with a char array, which is used to mention a string. Okay, and B char array, C char array, and then salary we can give as float. So we'll make these changes so that while we working with the commands, it's easier to work. Okay. And now if you describe, you can see that whatever you specified is there and the rest is byte array as usual. Okay, so this is your load statement. You can see again now. Load contains the file name enclosed in single quotes, then the pig storage function, that you know how the file is stored. Okay, and then you can give as, and then you can give a schema. Okay, and then you can use describe to see the schema. And the next one is the dump operator. If you want, you see, until and unless you dump or store, the MapReduce processes doesn't start. So this is simply loading the file into the relation. Okay, no processing is done on it as yet. So if you now dump it, then your MapReduce comes into picture. See, dump m. Now all your MapReduce jobs will start. You can read all these instructions carefully on your clusters. So these are the MapReduce jobs, and then you will see the dump would list the contents as a tuple. So we have 16 tuples because there are 16 records in your emp.txt file. So it is dump will convert it into 16 tuples, and you can do a lot of processing on these tuples, right? So dump is used to display the output of the files on the screen, of your relations on the screen, of the data sets on the screen. But since your data sets would be containing hundreds and thousands of records, it would not be a good idea to display them on the screen. A better way would be to store them in some external file. Okay, so for that we use the store command. Okay, how do we use the store command? Store, then your relation name, then into, and then in single quotes you mention, say, or you can mention as Ritik, like this. So what happens when we use this style is that a directory with the name of Ritik is created under the root of the HDFS. As I mentioned, this whatever you mention in single quotes is your directory name. Okay, so let's see this working now. You can see, and look on the screen, it will tell you how many records have been stored. For this file, you know there are 16 records. Okay, so you can see here successfully read 16 records from emp.txt, successfully stored 16 records in this folder Ritik. So if we go there in our web UI and look for this folder Ritik by refreshing our this thing HDFS web UI, then you see a folder Ritik is there, and within that there are two files: a success file indicating that the store operation is a success, and a part file which contains the actual records. Okay, so if only one mapper has been used, one part file would be there. So as many number of mappers and reducers you use, so would be the number of part files. So I can click on this part file, I can download this file, I can save it, and then I can display this file. Okay, so you can see the records now are being displayed by being stored in this file, but they are tab separated. See, they are not comma separated now. So why they are tab separated? Because while you were using the store command, you did not specify any storage function. Okay, you just mentioned this. You didn't mention any storage function, right? So if you want to use, this store this file as a comma separated file, then you must mention a store function here. Okay, so if we use this here, will it work? That is my question. You can raise your hands to answer this question. I'll be using this syntax so that my file, the data now gets stored as a comma separated values file. Okay, so people are raising hands: Rahul, Sunny, Mani, Ritik, Ritika, so many people are there. So let's ask Sunny.
Yes sir, good morning sir.
गुड मॉर्निंग सनी, आप लेट क्यों हो क्लास में? कोई प्रॉब्लम?
सर वही इंटरनेट इशू हो रहा था सर.
अच्छा, तो मैं जिस भी बच्चे से कोई प्रॉब्लम पूछता हूँ, तो दैट्स अ वेरी इजी आंसर. यू सी, नेटवर्क इशू, इंटरनेट इशू. नो, आई एम जस्ट सेइंग, आई एम नॉट सेइंग कि आप झूठ बोल रहे हो. नो, आई डू ट्रस्ट यू, but that means even in today's world we do have a lot of network issues.
Yes sir.
Never heard of them while we are in an entertainment mode, but yeah, in an academic mode we are facing a lot of network issues.
Nahi sir, during that time also there is buffering that happens.
So please answer this question. Will this work?
Sir,
yes,
this will give error.
Why?
So because Ritik is already created, it's a directory present.
Okay, so in a store command, if we are mentioning a directory and that directory exists, it will give you an error. See, you can see the error on the screen. It will say output location validation failed for Ritik. Okay, directory already exists, Ritik already exists. So what we can do is we can give a separate name here. Okay, we can give a name as Ritik1. All right, thank you, Sunny. Thanks.
Thank you sir.
So now we can go to our web UI and we can look for a Ritik1 directory. I think you can see the Ritik1 directory is there. You can see the part file. You can download it. You can save the file. You can click on it, and when you open it, you can see a comma separated now. Right? There's a comma separated value. So while with the store function, you can specify the separator. If you don't, then by default it is tab separated, the file that you are storing. And that means while we use store, it uses a directory to store the records. The records are stored in a file, true, but the syntax of the command tells you that it would store it into a directory, and within that directory it creates two files, a success file and a part file. If more mappers or reducers are used, that would be the total number of part files. So if 4 mappers are used, then 4 part files would be there. Fine. So let's have a quick poll here right now so that we see that whether you are up to the mark. Okay, the poll is in front of you now. Limited time, please. So easy question. Okay, closing the poll now. sharing the results with you. In my discussion, I just shared that if we are asked this question, then the answer obviously is directory. 85% of you are correct. Some people have answered both. Can I know their names, please? You can raise your hands. Those who have answered both, because we can discuss something worthwhile on this answer also. Those of you who have answered both as the option, 4 people have answered. You can raise your hands, please. No problems in raising your hands. One person has answered file. So file won't be the correct answer. Both can be taken up as the correct answer because it is using both. But ideally, if you ask, the store operator stores the data in a directory, and that is as per syntax. So you should be giving that answer. Okay. So let's see if we have any other question here. No, we don't have. Okay. So we have discussed store, we have discussed load, and we have discussed dump. Okay. Let's now go back to our PPT here. So we were discussing about the history command. Okay. I'm going to write the history command for you now. Okay. I'm going to write the history command. So I'll just write history. So you can see these commands we have used in history so far. Okay. Let me use another command here. See, you see there is no dump in this list. So dump command is not listed in your history. Simply because you see dump doesn't require a semicolon to end. See, I'll tell you how. Let's write dump and then M. I'm writing it without a semicolon, okay? It will work. So all those commands which can work without a semicolon, you know, they don't form a part of the history command. Okay, so if I again write for history, there is no dump there. Remember this thing, dump is not a part of the history. Let me write another command so that you are very clear what we are learning. I'll just write shell ls, right? So it will list the files from my local file system. Okay, so you can see the list of files. I'll use ls-l. It will list the files like this. But if I use history now, even these commands are not a part of the history. So only the commands which belong to the grunt shell are the part of the history. These fs and sh are the file system or the shell commands, so they won't be a part of your history command. And you can see the line numbers in history. Okay, so you can omit them by using the -n option. Okay, history -n would omit these line numbers from your history of the commands. Okay, I hope this is clear. The history command is clear, right? The next is the quit command we have seen. If you need to come out of the grunt shell, you can write quit. Alternately, you can press Ctrl D to come out. The kill command is used to kill some job, usually an admin command. You won't be able to test it. And if you want to set the number of reducers to 20 for your processing, then you can use this command set default _ parallel 20. Kindly remember this command. It would be useful later on. Set default _ parallel space 20 would mean that you are setting the number of reducers to 20 for your pig environment, right? Okay. The next is your clear and execute commands. Okay. So clear command we have seen. So basically we will be discussing the run and the execution commands, right? So let's have a look here. You see, run and execute, both are used to execute a pig script. So what is a pig script? Pig script is simply a collection of your whatever commands that you write in the grunt shell individually. If you just put them in a file, in a sequence, so it is executed in a sequence. So let me have a load command here, the detailed one, so that, yeah, this one. So I'll copy this. What I'll do is I'll copy this from here. Okay, and then I'll just open up a file. So editor I need to open. I'm in grunt shell, so sh gedit say a11. Okay, I open this file. I'll just paste the contents here. Okay, one command is here, and then I can write here dump m. I've written two commands in my file a11. So you can safely say that this a11 is your pig script file, contains certain pig commands which you can run. Okay, you can save this file. Okay, you can list its contents. So these two commands are there in your script. Now if you want to execute this script, okay, you can either use run or you can use execute. So let's use execute first. And remember one thing, just a second. Look at the history. The count in the history is 8 at the moment, right? Okay. I'm using run A11. So I'm saying run this pig script file A11. I've not given any extension to it, but ideally you should give an extension of .pig to it, just to remember that this is a pig script file. But otherwise you may or may not give any extension. So I'm running this file. By running this file, whatever commands are written in it are executed one after the other. So let's see what commands are there. These two commands are there, and then we can run and then the script file name. Okay. So both these commands, first the file is loaded, then it is dumped. Okay. So if we just go through on top of the screen, let's see how this has come up. Okay, I'll show you. You gave a run A11 command here. See on screen, run A11. Then it listed the first command on the grunt shell prompt, emp is equal to this, file was loaded. Then it listed it here also, dump emp. So that means that if I now see history, you will see these two commands also added. Obviously dump won't be there. So this 9th command is the load that you had. So that means run commands, they are a part of the history. Whatever commands you use, execute with run, some script file, and whatever commands are there in that script file, they become a part of the history. Okay. Let's now use it for the execute part now. So execute A11 would do the same. Okay. But the history would remain unchanged. The commands would not be a part of the history. So if you see here history, you don't have another emp loaded, the 10th function is not there. Okay. And while we executed this script, you can also see that nothing is listed on the screen. Look here on the screen. Here I started execute A11. So it just started, it didn't mention anything that what was the command in the file A11, neither the load nor the dump. It was not even displayed on the screen. So if you wish that whatever is a part of your script file should be known to you only, others should not see it on screen while it is being executed, you can go with execute. Otherwise you can go with run. Okay. I hope that's clear. If it's clear, you can give me a raised hand, all of you. If you've understood the differentiation between run and execute, you can give me a raised hand. All right, thank you. I've got your response. Thank you very much. Thank you. You can lower your hands now. Vishal Kumar, lower your hand, please. Thank you. Let's go further now. Okay. And look for some more commands. Yeah. Running the pig Latin code. So we have just seen how we can run our code from the grunt shell. The first thing that we have learned. Either we write the commands individually and they are executed, or by writing the commands in a script file and using the run or the execute commands to run the script. Then another way is that you can use while you are in the bash shell. That is the standard way of executing pig script. That is, you don't go into the grunt shell, because grunt shell is basically for your experimentation. Usually you have a script file which contains all the commands, and you can use this pig-e and pig-f options to execute these scripts. Okay, so let's see them one after the other, right? So let me reach here. Let me come out of the grunt shell. I can do it by pressing Ctrl D. Okay, so while I'm in my bash shell, what I can do here is I can write here pig-e. Okay, and in double quotes I can just copy. Yeah, it's still there. And then I can write dump m. Look now what I've written. I've written pig-e. That would mean execute whatever is written in double quotes, whatever statements are written in double quotes. Okay. And then a semicolon is used to separate the statements, but after dump we don't require a semicolon. You may put a semicolon if you wish. Okay. So now this would be looking for, you see you're writing pig-e, you're not mentioning any execution mode. So it would be looking for this file in the distributed file system. So I can press enter and I'll see the similar output that we have been seeing about our emp relation. Okay, got it? This we have done at the bash shell by using pig-e. Okay. And if I write it like this, say I write it like this, pig-x local-e. If I write like this, now this means, thank you. This means that we are now running. I want to load the file from my local file system, but the path here is incorrect because there is no root that is accessible to me in the local file system. So if I run this command here, it won't run. You can see here, now I'm going with the local mode, but there is no file as m.txt in the root. Even if it is there, it is not accessible. So it will say fail to read data from /emp.txt. Okay. So what we need to do is, we need to specify the correct path in the local file system. So I do have a m.txt in my local file system. For this, I need to mention this. This is my default path, the local file system path. Okay, or I can also give a detailed path also. So this will now display the records. I hope you understood pig-e. Okay. Then pig-f. Then instead of writing the commands, for short commands you can use this -e option. But for a large, number of commands, you store those commands in a script file and just run that script file. Remember our a11 script file. So just write pig a11. It will execute the script and will display dump the records on the screen. So if I just go up on top of the screen, let's see how it executes it. I write here pig a11. Okay. After that, it just starts running everything. Nothing is displayed. So that is a standard way of running. You don't know what is there in a11. Okay, but whatever is there is executed. So from the security viewpoint, this would be a better option to run your script. So this is similar to your execute command running here, right? Then you can also mention the -f here. -f means the file name. So whether you write -f or not, it picks up the file that you provide after the pig. Okay. But if I write here pig-x local, the same problem would be there. You understand this problem, that it will look for the file in the local file system, and your command in a11 is in the distributed file system. You can see here you've loaded the file in the /emp.txt. It won't be located. Okay. So this is regarding your running the pig Latin code using grunt shell, using pig-e, using pig-f. Okay. Any questions till this point? If there are any questions, you can please ask. No questions, all clear. That's very good. Very good. So let's see if there is any poll at this point. No, not yet. Okay, let's now discuss a few operators. Okay, let's run the word count program now. Okay, Mani has raised hand. Mani, please ask.
Yes, sir. Good morning, sir.
Good morning.
Sir, actually, I want to see, is that a11 file in the HDFS, because I didn't see when you.
No, it's not in HDFS. No, it's
Uh,
in my local file system.
But sir, when we execute from using a pig space and pig a11, and it should access from HDFS.
No, pig. It is your script file is here only. With these commands, you are in bash shell. So
Yes.
whenever you use pig-e or pig-f, your file should be in the local file system. You have the file in the local file system, the script file, and your data files would be there in the HDFS or local file system. That's up to you.
Okay, sir.
Understood?
Yes, sir.
All
Thank
right.
you, sir.
Okay. So let's review our word count program now. So for that, I'll pick up some file, say cat, see this file if it's there. Yeah. First we'll test with a small file. So I have a file with the name as test. Okay. Hello, how are you? I'm fine, good. These are the 4 lines of text. Same as the marry.txt example that we have taken. So I'll count the number of words in this. Okay. So I'll count the number of words in this. So let me look for my file. Yeah, this is the file. So let me open this file for you just to review the commands that we need for our this. So first I load the file. There's a file test in the distributed file system also. I load it and I give it the name as line 1 field and char array. That is one of my columns. And then I use tokenize. I'll use the tokenize and this flatten differently. Okay, so that you can see what is the effect, so that you remember what is tokenize and what is flatten, and you know that we can write it in one line also, in one command also. Okay, so let's close this. Let's start pig in the distributed file system mode, in the MapReduce mode. Let's clear the screen and let's open the file. This is my script file. What I'll do is I'll copy the commands from here one by one, paste it on my grunt shell so that I show you how they work. Okay. So I'm loading the file test. Okay. The file is loaded. Right? You can see it. I'll dump it for you. Kindly note this thing very carefully. This would be a good review of your word count program, right? So the relation A I'm going to dump. You can see those 4 lines. Hello, how are you? The one that we just saw. Can you see? They are listed as 4 tuples, 4 map tasks and 4 tuples are resultant. Hello, how are you? I am fine, go to college, come back. Now, what does the function, I'll just see this, yeah. The next one is the tokenize function. So what does the tokenize function do? Let's use this tokenize function on our relation A. Look on screen, please, all of you. You can see B is equal to for each A generate tokenize, and then I'm using the command line, the column name that I gave, and the output of this which would be stored in relation B, I've given it the name as token. Okay. Okay, I'm going to dump B now. Look very carefully what it converts. You can see hello, how are you is 1 line, I am fine is 1 line, go to college is 1 line, come back is 1 line. See what this tokenize does to each of the lines. Okay. Look on screen now. It will split them into words. See, hello, then how, all these are split up into words. Now I'll flatten each row of this relation B. I'll flatten it now so that hello is in 1 line, how is in 1 line, R is in 1 line, and so on. So for that, let's again copy it from here. Okay, I'm using this relation C, which flattens relation B on the token field. Okay, I'm doing it slowly so that you understand. See, okay, so now I've taken the name as token 1. Okay, token 1 is my new name for the column. So if I dump C, you see what the output is: hello in 1 line, how in the next line, and so on. You can see now. See how we are counting the words in a short file, and then we'll extend it to a huge file. See, these are the words. In every tuple there is only one. So we have one column now with the name as token 1, as you can see. Okay, we have the token 1 as the column name. So what we can do further is, now we group C all. You see, grouping can be done on one column or on the entire relation. So I'll just do here group like this. I'll copy it and I'll paste it here. So I'm grouping the relation C, and if you dump T, you can see the output. This is important for you to understand. So we have a all column. In when you group by some column, we have a group column, but here we'll have a all column. So in all column, we have all the entries. You can see that. Okay. So when we use count, it will just count all these entries. Okay. It will just count all these entries. This is basically, I'm not counting what word occurs how many times. I'm just checking the total number of words in the file in this program. This is a word count. Okay. There is also another way in which we can see occurrence of each of the words also. Okay. We'll do that next. Okay. So if I now use the last part of this, I can use a count function on my relation T. Okay. So I'm using for each T generate group comma count. So in group, in place of group, the word all will come, and in count, we will count the, I'm counting the first column. There is only one column, so I'm counting the first column. And if I dump D, it would tell you the total number of words in your file. Let's see how many words are there. So there are 12 words in the file. You can see it. You can count, there are 12 words. Right? 4, 3, 3, 2. 12 words are there. Right? Let's now discuss another program. Let's see this program. We can see word count. Yeah. So this will count the number of words, occurrence of which word occurs how many times, and then we can extend this to find the most occurred start letter case study that we did. Okay. So see again, I'll be working on first the mary.txt file. Okay. I'll load that file, and then I'm using whatever we did independently, flatten and tokenize as in one go. So you know what is the output of relation B. Whatever words are there, one word per line, it will be outputted. Okay. So I'll be storing that result into the relation Z11 in the folder Z11, and then I will be doing the grouping. Okay, grouping on the basis of words. Okay, so the similar words would be grouped together. Okay, I'll dump that also on the screen, and then I'll order it in a descending order so that I can see the words, maximum occurrence words first. Okay, so I'm going to run this. We'll discuss this also. This name is wordcount.pig. So I can just use run wordcount.pig. Okay, let's run this. You see the final output, and then I'll discuss it one by one. I'll show you the outputs also. Yes, Sunny.
Sir, if we'll describe B, sir, then what will be the structure of it?
We'll see. Just wait, okay?
Okay, sir.
All right. So I'm going to open the program for you now once again to see whatever questions you've asked. You can see we used run. See, we used run, so all the commands have come on the command line. Can you see? This was the first command. So let's run them like this. Load will load the file, B is equal to for each, we have run this. So Sunny has asked what is the structure of B. Okay. So can somebody give an answer to this? The answer is there on the screen itself. What's the big deal about it? Let's see. Sunny, I think you asked this. Describe B. See, B token char array. There is a column with the name as token, and that column we have given it the name as token. It contains words. Okay, so if you dump B here, you will see all the words from your file mary.txt. See now. You see all the words, one word per line. Right? Good enough, Sunny. I hope you've got it. And you see, Sunny, if you have understood, you can give me a raised hand, please. Or if there is any question, I can unmute you again. Understood, Sunny?
Yes, sir.
All right. So what we do further now, okay? We just group on this. We don't group on the all. We group on this column, okay? This column. The name is, just check the name of this. The column name is token. Okay, so see next. I've stored this B into Z11. We'll look at whatever is appearing on the screen is also a part of the file Z11. We'll see it there also. Okay, and then I group B by token. The relation B is in front of you. So these words are grouped together. So if you can see there are two Mary in it, so there will be one group. Okay, I'm grouping it and I'm showing it to you what it contains after grouping. Have a look at it. Can you see now? Look at Mary. Okay, Mary is one group. Okay, and in it there are two values, Mary and Mary. Lamb is one group, two values, lamb and lamb. Right? Was is one group. So it is just telling that if was is one group, how many things are there in it. Okay, and after this you will just count from the group. You will generate the group and you will generate the count. So it will tell you that was and then comma 2, Mary comma 2, like this. Okay, so I'll do that for you. This I did. For each C, generate group comma count B. You remember that in when you write generate, then in the count, whatever function you have, you write the relation on which the grouping was done. So grouping was done on relation B. And then if you dump D, you will see that which word occurs how many times. It will just total up the, right? I hope understood, right? And then if you want to, arrange it in some descending order, for that we have done this. We order this by $1. $1 is the second field. You see in this relation D, okay, there are two fields. One is A, the other one is the count. Okay, one is the group, other one is the count. Okay, so the name for that is $1. The first field is $0, the next one is $1. So you are ordering it by $1 descending. So the entry 2 would come first, then the entry 1, and so on. Okay, so if you dump E here, you can see that arranged in a descending order. For if you have a case study to find the most occurred word, then obviously the most occurred word would be the ones on the top. You can see Mary occurs, Mary, then lamb, and then was. They occur twice, okay, and the all other words once. Okay, so if you have understood this word count, you can give me a raised hand. I think we have a detailed discussion about it. If you have understood it, you can give me a raised hand. All right, thank you. So just for just for some fun, let's extend this to a bigger file, because you will say, sir, ये तो हम भी count कर सकते हैं, right? So let's count it from a bigger file. So let's open this file here, okay? And now instead of this file mary.txt, let's load the file dataset -movies.csv. Okay, this is a big file. dataset-movies.csv. So it will do the same task on this. It will tell us which word in this file occurs how many times. Okay. So let's check whether it gives us some result. So I'll just write here run word count.pig. Okay. Yeah, we have a store. Okay, we need to change that because these directories already exist, right? See the problem when you're executing, you need to be very clear. So let's name it as Z111 Z121. Now it's fine. So I'm running the file. There's some problem again. The file is not there. Oh, we did we miss? Yeah, we missed something. Okay, we are not careful. You are not careful, I suppose. So this file is not there. This file is not there. Let's look in our web UI. We don't have a file like this. Why it is not allowing us? Yeah, this file is not there. Dataset-movies. You can see in the root there is no file dataset-movies. So let's transfer it. No problems. Let's transfer it with the command put from our local file system to the distributed file system to the root. It's done. Now we can run word counter. Let's see now. Let's hope it gives us the desired result. So you can see the processing is going on, and let's see what's the final result. Because it is going to sort it, so descending order, so a lot of time would be there. Let's now go to our files in the distributed file system to see the results. So we stored it here, user HD user. We have Z111. Let's see first in Z111. So two mappers were used. It's a huge file. So there are two part files. Let's look for this part file. Let's save it and then let's open it. You can see this is the first part. The movie is The Nightmare Before Christmas. So all these words are split up into like, so this is the splitting up part. Okay. And then the occurrence and the count. Okay. Let's look for in the folder Z121. So here the reducers are used. See, while the map task is there, only the map task is there. So there the part -m is there. So once now the counting needs to be done. Okay, after grouping, counting needs to be done. So it is done by different reducers. So only one reducer is used here. Let's see its output. Let's open the file. So you can see the word season occurs 32,559 times. The word the occurs so many times, and so on. See the strength of this program. Okay. It has told you which word occurs how many times. So if it is clear, if this thing is clear, you can give me a raised hand so that we can move further with a few more operators. Yeah, thank you. I can see you have understood. All right, all right, all right. So let's move further. Next, I'm going to discuss with you the sample operator, right? I'm going to discuss with you the sample operator. So sample, as you know, is used to pick out a sample from Let's see if we have some presentation here for this, or we are finished. Yeah, maybe we. No, we have all Linux commands here. Okay, let's look for another presentation here. Maybe we can get something here, so that just we have a quick recap of some operators. Sample, rank. Yeah, here we have some. Yeah. So let's discuss these split and sample operators. We have discussed them. By name, it's clear. Split is used to split up your relation into two or more relations based on the conditions that you specify. So obviously, split is the opposite of join. And let's work with split. Okay. So we have a emp relation. Let's work on that. We have emp, so we can split up emp. Say split emp into A1, split emp into A1. If somebody can help me with this, raise your hands, please. Let's see your attention. Somebody can help me. I need to split emp into three relations, one which contains employees from department 10, one from 20, one from 30. We have done this thing before also, so if you can just help me with this. All right, many people are raising hands. Sunny, Mani, who else? Ritika, that's it, 3 people? Only 3 people. Okay, let's ask Sunny. Ritik has also raised hand. Yes, Sunny, please answer.
Hello.
Yes, Sunny, please answer.
Yes, sir. Split amp into A1 by, sorry,
Okay.
X1.
Hello. Your answer is not on track, I suppose. I'll help you somewhat. Just a second. Yeah, people are still raising
So
hands.
split X.
Yeah, wait. I'll give you the schema so that you are clear. That would be easier if you can see the schema. Yeah, we can just write describe. Describe is not there.
Yes.
So we missed it. Okay.
So
Wait. Should be there. We did it the first thing now. Yeah. Okay. Now we have describe emp. You can see, right?
yes.
So you know which this thing to do.
So department number is in
Department number is H.
H. Okay, sir.
Yeah.
So we'll split amp
Hmm.
into
Okay.
X1
Okay.
if
Hmm.
H is equal to double equal to matlab
Hmm.
10
Hmm.
comma X2
Okay.
if H double equal to 20 comma otherwise semicolon enter.
Hmm?
Semicolon and enter.
Otherwise में कुछ नहीं लिखना और.
नहीं sir.
Otherwise means कि अगर
Else.
10 है तो x1 में, 20 है तो x2 में. Otherwise लिखना पड़ेगा ना ऐसा कुछ x3.
अच्छा
ऐसा लिख
X3.
दीजिए.
Okay sir.
मुझे नहीं पता आप लिखवा रहे हो. एंटर कर देते हैं. जो गड़बड़ है इसमें कुछ.
नहीं तो X3 if H equal to 30 भी लिख सकते हैं.
वो तो लिख सकते हैं. आपने अदरवाइज बोला ना. ऐसे
Yes,
करके
yes.
देखें. अभी भी ठीक नहीं है. देखो. क्या करें बताओ.
X3 otherwise.
वैसे करके देख लेते हैं. आप जैसे बोलो. x3 अदरवाइज, राइट.
Yes,
ये बोल
comma.
रहे हो? कॉमा आएगा क्या? ऐसे. This seems good.
Yes.
देख लेते हैं. अब बने कि नहीं रिलेशन. डंप नहीं करते, डिस्क्राइब ही कर लेते हैं. ठीक है. डिस्क्राइब x1, डिस्क्राइब x2, डिस्क्राइब x3. ठीक है. This correct. Anyone who wants to suggest something more? Let's see. Mani ठीक है ये?
Sir, the statement
Yeah,
that
the,
Sunny said.
yeah.
Yes, that's correct.
Okay. All right. Fine. Thank you.
Thank you, sir.
So this is a split, right? And then next we have the sample operator. So sample is used to, whenever you are, you want to pick up a small part of a data set just to see whether it is worth, working with. So you can pick up a sample from the data set. So the syntax is sample, then the relation name and some expression, where expression is any value between 0 and 1. So 0 means 0%, 1 means 100%. So 0.1 would mean 10% and so on, right? So let's work with this sample. Do we load the, let's load the bigger picture here. Let's load a bigger file so as to see the statistical aspect of this. Let's use the file dataset -movies.csv, right? This file should be there. We can dump it fast. And then we can work with some ranking and all, some samples. You can see there are about 50,000 records in this file, which will scroll in front of you on the screen. Okay, 49590, right? So this is the total number of records, 49590. Let me take a sample out of it. So obviously we require a relation name here. A is equal to sample M 0.1. So I'm going for a 10% sample. So 10% of around 50,000 should be around 5,000. So 4,900, something like this. Okay. So let's do it. And let's, you see, dumping won't help us to count. So let's store it. So store A into P1, some folder P1 here, right? And I think I've missed something here. Yeah. Okay, I am taking a 10% sample from this data set, which contains around 49,590 records. Okay, so let's see, we have seen it before also. It was fun seeing how it randomizes and picks up the records. We'll see how many records, 4,900 or what. Yeah, so we have a sample of 4,873 records. Okay, if I run it once again, if I another dump, another map reduce of this, sorry, another store would be a better option. Yeah, into P2 now. Remember, it is 4873, and the next will give somewhat similar range here, but different set of records. Okay, so 4873, now we are looking at maybe 4,900 or something like this. Yeah, so it is 4982. Okay, so variations are going to be there because it is based on some randomized algorithm. What is that? I think you can have a look here. Okay, so you can also run it by using this. If your relation, you can use this random function less than equal to 0.1. This is what sample does in the background. Okay, so if I just copy it from here. Okay, I'll use it here. My relation is emp, so I can write here w is equal to, then I can just paste the text here, filter emp by random this. So this is again the same thing, a 10% sample. Some problem? Yeah, I think the function name should be in caps. Yeah. Okay, and then you can again store a P3 here to see what 10% is this time around. So it is 4916 this time around. So I hope you've understood the sample operator. Any questions on sample? You can kindly raise your hands, please. All right, no questions. Great. So next we have the split sample. Let's have the rank operator. Okay. So rank operator, it provides a rank to every tuple of the relation that you specify. By default, the rank starts from 1 and moves ahead in an ascending order sort of thing. Rank 1, 2, 3, 4. So either you can rank a relation. Ranking a relation would just assign the ranks 1 to the first tuple, 2 to the next tuple, and so on. But if you rank based on some criteria, then obviously the ranking would be different. Ritik has raised hand. Yes, Ritik.
Sir, when we load some file as line colon char array,
Yeah.
instead of line colon char array, you have said that we could also use $0, right?
Instead of line colon char array, that is the name of the column. The name of the column is line. So while you are
Yes, sir.
using it in projections, either you can use the word line, okay, or you
Okay.
can use the word $0 if it is the first field in your relation.
Okay, sir.
Fine.
Yes, sir.
So let's see this ranking part now. Okay. Let's load it again with our emp. Yeah, this one. Okay. Remember, F is our salary. We'll be ranking on salary. Okay. So I've loaded the emp dataset. I can display it also, and then I can do the ranking. Okay. Kindly pay attention how ranking is done. Two ways I'll tell you. These are the records. If I simply say R is equal to rank M, that's it. Okay. Then simply the first tuple will have the rank 1, that is the Smith. The ln will have rank 2, and so on. Okay. If I dump now, you can see the ranks given in a sequential order starting from 1. So we'll have 16 ranks now. So this is ranking without any condition, which is usually not the idea. You can see the 16 ranks. Okay. What we would like to do is rank emp, and then by using this by option, okay, and then the column name. So I'll pick up F, which is the salary. Okay. And I don't mention anything after this. See, I've done this. I'm ranking emp by F. So I'm ranking emp on the basis of salary. So look at the records in front of you and tell me what is rank 1, which record? Rank 1 and 2. Okay, rank 1 and 2 you need to tell, right? Rahul, rank 1 and 2. Yes. Rahul, unmute yourself.
Good morning, sir.
Good morning.
Sir, it is Smith and James.
Smith and James. Okay, yeah, right. So 800 is the salary here. James is having 950. So when I rank and I don't mention anything, it is done in an ascending order. Lower salaries first and higher salaries later on. Okay, fine. So let's dump this, Rahul, to see this, whether it is what you are saying, whether we have the same output. We're seeing the output now in front of us. It should be like what Rahul has suggested, but let's have a look. Ranking is rearranging, so an expensive task takes some time. Okay. Yeah, it's there. Smith 800, James 950, and so on. Okay. Rahul, stay with me. Don't go.
Okay, sir.
Rahul, now we are going to do it on G. That is a commission. Okay.
Okay.
So you tell us now what would be the output. While it is coming, you can tell. मैं डंप कर रहा हूँ, आप बताइए, देख लीजिए एक बारी.
Null values पहले आएंगी.
हाँ.
Null values.
Okay.
It
Null
is
values
sure.
को rank 1, सभी को 1 मिलेगा rank.
No, sir, अलग अलग जाएगा.
Okay, okay. सभी को अलग अलग मिलेगा. सभी null values अलग हैं कि एक ही होती हैं?
एक ही होती है सर, मींस कि लाइंस में आएंगी एक ही सर.
नहीं, एक में तो एक हो गया, तो फिर that means अगर 7 null values है तो first जो 7 rows हैं उनको rank 1 मिलेगा, right? उनको rank
No,
क्या
sir.
मिलेगा? No?
हर एक को डिफरेंट मिलेगा, आई थिंक.
Okay, let's check. Stay with me, Rahul. Let's see what you are saying, whether it's correct or not. ठीक है राहुल, यू गेट द आंसर नाउ?
ओके
जब
सर।
सभी नल वैल्यूज एक जैसी हैं तो उनकी रैंकिंग अलग कैसे हो सकती है? ओके, वन थिंग मोर राहुल, अब सभी पहली 7 जो नल वैल्यूज हैं, जब हमने रैंक किया है तो नल वैल्यूज को मिनिमम वो टास्क देता है, मिनिमम वैल्यू देता है। सो पहले नल वैल्यूज आएंगी, उसके बाद जो नेक्स्ट कमीशन है फिर ऐसे इस तरह से आएंगी। सो आप देखिए पहले जो 8th रैंक है वो 800 का है, फिर 8th रैंक, फिर मतलब सॉरी 8th रैंक है जिसमें 100 है कमीशन, और 8th ही रैंक है जिसमें 100 है। सो दीज आर नॉट कॉन्टिन्यूस रैंक्स, दिस इज हाउ एक्चुअली रैंकिंग इज डन, राइट?
ओके
अंडरस्टूड राहुल? सो अगर मैं
ओके
चाहता हूँ कि पहले तो सारे 1 है ही है ना, नल
सर।
वैल्यूज तो 1 आना ही है। इफ आई
यस
वांट कि उसके बाद कॉन्टिन्यूस रैंक्स हो, दैट मींस इफ आई वांट दैट जेम्स शुड हैव रैंक 2, मिलर भी 2 होगा, उसके बाद फिर अजय शुड हैव रैंक 3, लाइक दिस। इफ आई वांट कॉन्टिन्यूस रैंक्स then I should do this, like
टेंस।
I should write this tens. Okay, see the difference in output Rahul now.
ओके सर।
I hope all of you are noting down this thing. The dense option would give you continuous ranks, so you use rank and dense to get continuous ranks. So जिस तरह की भी आपको ranking चाहिए, you can use the appropriate option. Okay, you can see now it's a continuous rank now, there is no gaps. Okay, fine. Thank you Rahul, you can mute yourself.
थैंक्स।
Now let's have some quick polls. Answer fast, the poll is in front of you. Okay, last 5 seconds. Yeah, I'm ending the poll now. Sharing the results with you. 90% of you are correct. It picks up a percentage of records. Filter records could also be one of the options. So I don't even, I don't say that the 3 people who have done it is incorrect, but ideally you should pick up the third option. Okay, fine. Another poll coming up, the last one for the day. Yeah, it's in front of you now. It's the easier one, I think. We just did it. Five seconds more. Closing it now. So sharing the results, 97% are correct. Only one person has given the incorrect answer, that is rank without dense. May I know who has answered this, rank without dense? There's no problem, that is incorrect answer, but there's no problem in accepting that. Who has answered rank without dense? No one is willing to give an answer to that. Okay, fine. So that is regarding the polls. So I think that should be the end of today's lecture. I'll just close this meeting now.